Okay, last video on this topic here, at least for the time being. And we are going to talk about repeated, excuse me, we're going to talk about repeated zeros, which is another way of saying a double root. And if you remember what a double root looked like with a quadratic, it's when you had a quadratic that basically came down, right, and just sort of touched on the x-axis and then went back up, right? And this could be kind of like the equation of this, like x minus 2 squared, right? And the reason it's called a double root is because if you take both of these and solve it, so if you take this first one, right, you get x equals 2, and then if you take the second one, because there's two of them, it's obviously the same exact thing, right? So you get this root twice. So when you get a double root, okay, when you get a double root, so that's right here. This is a double root, okay? Now, that's only part of the story, all right? So what it means, all right, is it says if a factor is repeated an odd number of times. Now, you might be thinking, oh, wait a minute, a factor being repeated, what are they talking about? Well, let's check this out, right? So if we've got this graph right here, right, and we've got 0, we've got 2, and then this touches at 5, right? So the thing is, like, it goes through here, right? And this, I know it's at least a double root, but it could also be a fourth root, because if you had x minus 2 to the fourth power, it would look kind of the same as this. It would just look a little steeper. That's it. But it would still touch in the same spot. So we don't really know. We don't really know what that is. We kind of make assumptions about it, right? And the other thing we don't know is when a factor, so that's getting back to this, when a factor is repeated an odd number of times, right? So let's say we have this right here, okay? So we would look at that, we would say that's 5, so it has to be x minus 5. But the thing is, we know it's not squared, because if it were squared, then it would kind of go up like this right here, right? But if it's to the third power, what happens is it does do this little loopy thing. So this could be a triple root, right? A repeated zero, right? This could be a root to the second power, to the fourth power, to the sixth power. So when it touches, right? So when it's something that just kind of touches the graph, it doesn't matter what's going on there or there, right? But when it just touches the graph, there is an even number of roots, right? It's an even number of roots, okay? And when it goes through it, so like here, the 0 could be more than one root. It could be 3 of the roots, it could be 5 of the roots, it could be 7 of the roots. Same thing with this 5. This 5 could be 1 of the roots, it could be 3 of the roots, 5 of the roots, and this point right here too, and we'll just say for the record that this is negative 3/4, all right? That's kind of what I was going to say it was. So, same thing. This could be 1 root, it could be 3 roots, it could be 5 roots, all right? And so just remember that it says it's repeated an odd number of times, all right? So basically they're saying, what is that exponent up there, right? And so if you only have it once, if you only have x minus 5 once, remember that's kind of the same thing as saying to the 1 power. Well, 1 is odd, right? So it kind of falls in that. Okay, so let's write this equation then. So we've got x plus 3/4, so we're going from left to right. That's this one. Let's clean this up right away. So let's take this and let's multiply by 4 to get rid of that. All right, if you're not sure what I'm doing, watch the earlier videos. All right, and so you get 4x, and when you multiply this by 3/4, you get plus 3, right? This one, remember, whenever you get 0, it's just x, right? So we've got x over here, and then we've got this, so I know this is at least a double root, all right? So I'm going to call this, it's going to be x minus 2, because the 2 is positive, right? And so it would be minus, it would be the opposite. And I know it's at least twice. All right, so we're going to go x minus 2 squared. Okay, and then this last one here, we're going to call this x minus 5. And it could be once, it could be several, it could be 3 times, it could be 5 times. So there's several different things that could fit this graph, right? One of the graphs. We would have to try this out to kind of see like which one exactly it is. But an equation of it that, just given the information we have, right, we know that one of the equations of this could be f of x is equal to 4x plus 3. We're going to put this x out front, right? X, put him in front, so that's taken care of. This is taken care of. And then we'll go x minus 5, and then we'll put our double root last. All right? And then keep in mind that this could be to the third power also, right? This 4x plus 3 could also be to the third power, even the fifth power, right? But we don't know that for sure. So it's just kind of a matter of, obviously this isn't the best way to get your equations, but it's one way you can get them, and it's good to kind of understand this sort of behavior about graphs and how that works. Sorry, I erased half of this one. I was getting rid of it. So that's our equation of this. Okay, apologize for the mess, but so you gotta put on your thinking hat when you do this a little bit, right? It's otherwise it can kind of sneak away from you. Okay, so hope this has been kind of interesting, if nothing else, making those connections, and have fun with your practice. All right.